Kumusta mga bata? How are you this time? I hope everyone is okay. Knowing that we are in the new normal state, please don't forget to observe our health protocols when you go outside. But since we are on the modular learning modality, I assume that you are just in the comfort of your homes. I do hope that you're done with some, if not all, of your learning activity sheets. Are you ready now for our new lesson? But before that, let's recall first some of the circular terms: the chord, the diameter, and the radius. Can you still remember those terms? Those were in week 2 of your learning activity sheets. This is our circle. This is the chord that connects 2 points on the circle. And this is the diameter that passes through the center of the circle and divides the circle into 2 parts. This is 180 degrees and another 180 degrees. And this is the radius, 1/2 of the diameter that connects the center of the circle and a point on the circle. But what if there are more than one chord, diameter, or radius in a circle? How do you call this? Or what is the plural form for chord, diameter, and radius? So for a chord, it is chords. For a diameter, it is diameters. And for the radius, there are 2 plural forms. One is radiuses, which is the conventional English form. And the other one is, how are you going to read this one? This is radii, the Latin plural form of radius. Again, what is this? Radii. So please do not forget this one because this is the commonly used word in mathematics. You might be encountering this in your senior high school or in your college. Again, this is radii. Now, let's move on to our new lesson. Each one of you is expected to calculate the measure of the central angle, inscribed angle, and intercepted arcs. Specifically, determine the central angle, inscribed angle, and intercepted arcs. Define central angle, inscribed angle, and intercepted arcs. And lastly, grasp the concept in solving the measure of the central angle, inscribed angle, and intercepted arcs. I have 2 figures here. Which do you think is the central angle and an inscribed angle as well as their intercepted arc? Can you guess? Well, this is the central angle and its intercepted arc, while this is an inscribed angle and its intercepted arc. So basing on these given figures, can you describe what is a central angle and an inscribed angle? Do you have any idea? So, a central angle is an angle whose vertex is on the center and its sides are the radii of the circle. While an inscribed angle is an angle whose vertex is on the circle and the sides are the chords of the circle. Again, a central angle is an angle whose vertex is on the center of the circle, while an inscribed angle, the vertex is on the circle. In what scenario of your TLE class, particularly in cookery, wherein central angle and its intercepted arc can be pictured out? Can you imagine? Well, it is the slicing of the pizza and the circular cake. And what about in your Araling Panlipunan? Grade 9 or grade 10, I think, in your economics class, that central angle and its intercepted arc are pictured out. Can you think or can you imagine? Yes, it is when your teacher presents the pie graph. So this is the example of a pie graph. So that means circles, central angles, intercepted arcs can be shown not only in mathematics subject, but in any subjects too, and in our daily life, like motorcycle wheels, bicycle wheels, the wheel of fortune that is shown in Filipino TV shows, and so much more. And what about their measures? How are we going to solve them? I have here a figure. Wait a second. I have here a circle O with a diameter, 2 chords, and a radius that forms an inscribed angle, a central angle, and an intercepted arc. Supposing the measure of angle A is 40 degrees, what will be the measure of arc CB? So, if this is 40, this would be 80. And if this is 80, this central angle is also 80. Because the measure of the central angle is equal to the measure of its intercepted arc. And the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Or in other words, the measure of the intercepted arc is twice the measure of an inscribed angle. Again, the measure of the central angle is equal to the measure of its intercepted arc, and the measure of an inscribed angle is 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of an inscribed angle. So, what will be the measure now of angle A, O, B, and R, AB? Again, angle A, O, B, and R, AB. So, if this is 40, this will be 80. And, again, as what I have said, that the diameter divides the circle into 2 equal parts. So this will be 180. If this is 80, how much is this? Again, if this is 80, how much is this? Correct, this is 100. How did I get 100? This is 180 minus 80, so this is 100. And what will be now the measure of angle AOP? This is the central angle and this is the intercepted arc, so this is 102. I have here another figure for you to practice. Give what is asked. Do you have your answers now? Compare your answers with mine. So what is your answer for number 1? Angle ACB is 30 degrees. For number 2, angle AOB is 60 degrees. Number 3, angle AOD is 120 degrees. Number 4, arc DC is 60 degrees. Number 5, arc BDC is 240 degrees. And the last for number 6, arc AD is 120 degrees. Congratulations! You got a perfect score. Keep it up. Since you've done a great job, let's make it more excellent by answering another set of problems. As shown on your screen, the problem says, your teacher in Kokiri told you to divide the pizza into 2 equal parts. The first part will be divided again equally into 4 parts, and the other half will be divided into 6 parts. Calculate the measure of each central angle and the respective intercepted arcs. We have reached the end of our discussion. I expect that you have learned more today, and I hope that you will ace your summative test. Good luck, God bless, stay safe and be healthy. Always remember that you are Math Talino. See you next time. Bye-bye!